Hello and Namaste.
I am Srishti Hada.
And I am Lau Moharjan and we are from Softwel. Today is part 3 of our brief virtual training session and we are going to show you the basics of working with canal profile in SW Canal. If you are new here, watch previous videos because this is a continuation series of brief virtual training session on SW Canal. Having said that, today we are going to learn about canal profile. This is a sample canal data that we extracted from previous Excel sheet. In this video, we can learn about the parameters used in profile of the canal. Here, in Profile tab, there are two views. First, Model View at the top and second, Data View at the bottom. In Model View, many lines are being displayed which are color-coded, which description is given in the bottom right. For example, pink line indicates canal bed level, green line indicates ground level. One thing that we all have to keep in mind is that we start the design from the end. This is usually done to reduce errors, but if you want, you can always start from the beginning. Now, we can see that the bottom left of the model view gives the chainage and elevation of the mouse cursor. If we move the mouse cursor to the ground level at the end of the canal, it shows a certain value of elevation. Always keep in mind that the ground level elevation and canal bed elevation at the last point of the canal will be equal when the profile is created for the first time. You can now see that the elevation of last chainage is equal to the elevation of existing ground level. It can be changed manually from the top left panel. Here, enter the elevation of last chainage, then click on Run. Now, you can see the change in canal bed elevation at the last point.
Now, let's discuss the components on left panel of the profile view. Just below Design Canal Bed Elevation at Last Chainage, you will see a group box containing chainage, elevation, bed slope, bed width, side slope, Manning's N, and drop. These shows the respective values as per label at the current section of the canal as indicated by the orange line in the model view. Then, below that you will see right and left arrow which is used to jump back and forth to your desired chainage. Then, you will see a magnifier which will zoom to the current chainage of the profile. Now, just below Run, you will see H scale and V scale which stands for horizontal scale and vertical scale. We work at horizontal scale 5000 and vertical scale 200 for easiness, but you can change it if you want to. For instance, let's change the horizontal scale to 2000 and vertical scale to 500. Likewise, let's turn on the scale and set CH or chainage interval to 100. It will display chainage at 100 meters. Again, let's change the RL interval to 0.5. It will display reduced level at 0.5 meter interval. Now, with the same setting, you can also turn on grid. And if you turn on auto, it will show grids with respective zoom levels. For instance, if you zoom in or zoom out, the horizontal spacing and vertical spacing of the grid changes. And you can also turn on or off remarks. The last one is the text height. You can also change the text height of the scale of profile according to your requirement.
Now, to understand the data view, first we need to keep in mind, as we have already mentioned in our previous video, that in data view, the red ones can be edited, but the blue ones cannot be edited. Here, we can see chainage and ground elevation that cannot be changed. Next, we come to design discharge that is given in cubic meter per second. We can calculate this design discharge data from crop water requirement or MIP method. For now, we leave it as per the default value. Now, to understand the drop, which is given in meters, first we need to keep in mind that we need to incorporate heads usually due to branching of canals or presence of any hydraulic structure, and also where there is a drastic change in ground level. Moving on to bed width, we need to keep in mind that the ratio B by D is over here. The blue one, which we cannot change manually, should be somewhere around 2. To get the value around 2, hit and trial the value of bed width. Timely execute design either by hitting the play button present in the toolbar or by pressing F5. Next, we have side slope. Just know that if you are designing rectangular canal, the side slope will be 0. And if you desire trapezoidal canal, generally the side slope is taken as 1.5. Having said that, moving on to Manning's coefficient. This can be altered according to the materials used in canal lining. Generally for concrete, we use 0.015 and for earthen canal we take 0.025. The value can be changed according to the required type of canal and its lining. We can find these values in different design manuals. Having said that, we now move on to the freeboard. Here, we generally take freeboard as 0.5 meter.
Now comes the main challenge, the mean flow velocity, also the blue colored one. The velocity has to be non-sitting and non-scouring. If the velocity is low, silt particles in the water will settle down. We do not want that. And if the velocity is high, the water will take away particles from canal bed, canal wing, which shouldn't happen as well. That's why we try to maintain the velocity from 0.2 meter per second to 3 meter per second. Now, if we visit the rightmost portion of the data view, it has 4 remarks. If you give any remarks on any changes you like, it will display in the model view like this. Make sure to check the remark on the left panel. Now, what if the required changes is not there in the data view? For that, select the downstream change, right-click and click Insert Row. Set the desired changes and it will put the values only on the red color parameters by interpolation. But if you execute it, it will also fill the values in the blue color parameters. For example, if you want to have data at changes 0 plus 192.255, click on the next adjacent changes, which is 0 plus 200, and right click. Then insert row and put the required change. Click on OK, then execute. You will see all the data in blue ones are also filled. Another method to insert a changes is by going to Data, then going to User Change. You can insert the changes manually in this table. Click on Save, then go to DTM, click on Update Terrain, and a dialog box will appear. Here, click on Include Users Change and click on Process. Now you will see your desired changes has been included in the data view. If you follow this, you will not need to update terrain and then execute, as the value inside blue color parameters have already been processed. Now, talking about branch or off-taking canal. The elevation of full supply level, FSL, in branch or off-taking canal should be lesser than that of the main canal. It has to be at least 0.2 meter lesser than that of the main canal, else the water will not flow to the branch canal. If FSL of branch canal is more than that of main canal, error indicators highlight the errors in red circle. To fix this, you can either hit and trial on main canal or branch canal or both.
Now, let's see how we can add hydraulic structures. For that, we go to Plan. Then on right side, we see an Insert Structure button. Click that. A pick point command gets activated. Now, click on Alignment where you want to add a hydraulic structure. A dialog box will appear where the changes of that particular point will be shown. Now, choose Structure Name and Structure Type from the drop-down menu and click Apply. You will see the structure being added in the plan. Now, switch the tab to Profile and check Remarks on the left panel. You will see the added structure in Remarks form with Chainage and name being displayed.
So that was it for part 3. We will see you in the next video. If you find this video helpful,
and if you want to see more of our videos,
hit that subscribe button. Also, don't forget to like, share and subscribe.